So in this video, I'm going to go over number 5 and 6. Here's a system at equilibrium, and we don't know the tension. This tension, we'll just call it T. We don't know that tension. We don't know this tension T2, and we don't know the weight. Let's start with the simplest picture, the box, simplest box, this one over here. We know the sum of the forces in the y direction equals 0, so the up force is T and the down force is 60. So right away I put this right into the picture, and we're going to make this 16. We'll give these two significant digits. So I've got that. Now I focus on this. There's a weight of W, there's a tension going this way, and there's a tension going that way. So that's kind of a cheap and easy way for me to do the free body diagram. So right away I think I'm going to do the sum of the forces, since this is in equilibrium in the x direction equals 0, because I can say I can get T2. So T2 cosine 53.13 degrees equals 60 newtons. When you solve for that by dividing whatever cosine 53.13 is, I'll divide and I will get 100 newtons. Or really, technically 1.0 times 10 to the 2 newtons. That's in two significant digits. Now that I've gotten this, I think I'm going to clean this up a little bit. Get rid of that. Now I am going to get T. I got T2, now I got to get W. So I do know that, I'm going to get rid of that. I do know that the sum of the forces in the y direction also equals 0. So 100 newtons times sine of 53.13 degrees equals W, and that W turns out to be 80 newtons. Make it two significant digits, and that's that. Let's do the next one. Let me first clean this up. And let's go to over here at 6. This tension obviously is 60 newtons. And you know what? That makes this tension, we have a massless and frictionless pulley, that's 60 newtons. And now I've got the tension that is, whoop, they didn't even ask for the tension, but they do want T2. Right away though, I see I can get T2 by focusing on this box and saying the sum of the forces on this box in the x direction equals 0. So T2 cosine of 53.13 degrees. So that's the left force. There's another left force that's 30 newtons, and it equals the only right force over here, which is 60 newtons. And so I divide both sides by 30. I subtract 30 from both sides, do the math, and get that T2 equals 50, look it over here, 50 newtons. Yeah, that's 50 newtons. Put the decimal there. Now we can actually find W, because also the sum of the forces in the y direction equals 0. So T, it's getting a little, let me clean it up. So we want to get now W, and we do know there's one up force, that's the vertical component of T2. T2, whoops, sum of the forces in the y direction equals 0. T2 sine theta, actually, we know that it's actually 53.13, so let's erase that. 53.13 degrees, that's the up force, and there's only one down force, that's W. And so it turns out that that's 40 newtons. So this is 40 newtons. Oops. And what we got before is 50 newtons. So that takes care of that.